All right, so yesterday we started our investigation using GeoGebra about the interior angles of a polygon. And so today we're going to solidify that with some notes and some equations. So remember how we had seen that when we drew in the diagonals of our shapes, it created more triangles. So our interior angle sum increased by 180. That means for our equation, we're going to have the equation 180 times the number of sides minus 2. N is the number of sides. Okay? If you want the measure of each interior angle, so one interior angle, if it's regular, you're going to take your interior angle sum and divide it by n. So 180 times n minus 2 divided by n. The notation that we use is sum of the interior. S with a little I. Okay, so if you take a look, what's the sum of the interior angles of the polygons below? Of a heptagon, you should have learned yesterday, that means your number of sides is 7. If you go to substitute that in, and we want the sum, right, keyword, of the interior, 180 times 7 minus 2. So if you put that in your calculator, that's 180 times 5. Which 180 times 5 should be 900 degrees. And remember that 5 came from the 5 triangles that were formed. For a nonagon, our n is 9. So we'll have 180 times 9 minus 2, or 180 times 7. So that's 1,260. All right, so now we got to work backwards if you look at number 2. I'm giving you the sum of the interior angle measures. You have to find the number of sides. So now we're looking for n. You don't know what n is. So that means you're going to set this equal to your equation, 180 times n minus 2. You have a couple options. You can distribute and then get the n by itself, or you can divide by 180. I'm going to show distributing. So you will have 2,700 equals 180 n minus 360. Add 360 to both sides when you solve. And when you do that, 2,700 plus 360, 3,060 equals 180 n. Once you divide by 180, 30, 60, divided by 180, you should get n is 17. I'd like you to try B on your own. Pause the video, try out B. Okay, now we're going to look at number 3. Find the measure of each interior angle of a regular octagon. Keywords here are each interior of an octagon. So that means if it's an octagon, our n is 8. Since we want each, we want 1. So that means we'll be doing 180 times n minus 2 all over n, right? Because we only want one of them. So you're going to substitute it in, 180 times 8 minus 2 all over 8. So it should be 180 times 6 over 8. And if you do that, you should get 135 degrees. That means each interior angle of an octagon is 135. Now, for number 4, we're going to have to work backwards again because it says, given each interior angle of a regular polygon is 156, you have to find the number of sides. So now, again, we don't know what n is, so we're going to have to use this equation and work backwards. So what that means, is if you have your regular polygon interior angle measure is 156, that means you can set the 180 times n minus 2 over n equal to 156. Now from here you might be thinking, well, I don't know how to solve this if it's a fraction equaling a number. In order to do that, you can take this 156 and divide it by 1. It'll make it into a fraction without changing the value. So then you can cross multiply just like we